Swayam Prabha. Digital India. Educated India.
Welcome back to my course on industrial biotechnology. Now, in the last class, I tried to discuss the cheese making process. Now, I am going to switch over to the other type of products. The one, you know that nowadays we have been facing a lot of energy crisis problem because most of the energy that we use for our requirement usually comes from the fossil fuels. And if you look at this fossil fuel, they have the restricted storage. After some time, this storage will be exhausted. So naturally, that it is a major concern of the scientists that how we can generate the alternative energy sources. And it has been observed that renewable energy sources plays very important role. And as per renewable energy sources, that we have different type of renewable energy source. First, the things comes that is the solar energy. Then we have this wind energy. Then maybe your tide energy. So different type of energy sources we have as per renewable energy. But the one important thing is that the biomass. Biomass also can be used for different purpose because it can be also converted to some different energy source, and what we consider as the bioenergy. Now coming to lecture, I shall concentrate on some two type of chemicals which largely is considered as the promising biofuel for the future. One is biodiesel. Another is biobutanol. Butanol also used as a good substitute for fuel. Now, in this lecture, I try to concentrate on biodiesel, and as per the biodiesel is concerned, that it can be produced from different sources. It can be produced from vegetables, so from the seed, it can be produced. And also it can be produced from the algae, because algae is we know that algae is considered as a third generation renewable energy sources because the major advantage with the algae that it required very small amount of land for the growth of algae, and we can produce huge quantity of lipid out of that, and this lipid can be converted because lipid or fat that present in the algae or the oil seed, that in presence of methyl alcohol and catalyst, it undergo kind of esterification process, and it produce the biodiesel and glycerol. This is the major product that we have. This lecture I try to concentrate on that, and we'll see that how this process is in operation. As far India is concerned, that we know that India government they are also, because I told you that whatever good petroleum reserve we have in India, it is for very limited period, hardly for 30 years. So government of India, they encourage that for other type of energy sources, and the biodiesel is one of the promising area. And we know that Jatropha and other oil source that largely explored to find out this biodiesel potentiality in India. So if you look at this biodiesel, the ASTM International defined biodiesel is the mixture of long chain monoalkylic ester of the fatty acid obtained from renewable resources to be used as a diesel engine alone or blended with diesel oil. So, that it can be used in combination or it can use separately. So, blend with diesel indicate the BX, X means percentage of biodiesel in the blend. That means, for instance, if we say B5, it indicate that a blend of 5% biodiesel and 90%, 95% of diesel fuel. When then we call it B5. The advantage of using biodiesel is a renewable fuel, because it cannot be renewable means it cannot be exhausted, because it will be available with respect to time. It is available, it will not be exhausted. That is why we call it renewable. So, this will be with us throughout our existence. And what we call sustainable, this is quite sustainable for longer period of time. So, renewable, it is called renewable fuel obtained from vegetable oil or animal fat, that low toxicity as compared to the diesel fuel, and degrade more rapidly than diesel fuel, and minimizing the environmental consequences of biofuel spills. That lower emission of contaminants like carbon monoxide, particulate matter, polycyclic aromatic hydrocarbons and aldehydes. Low health risk due to reduce of emission of carcinogenic substances, and no sulfur dioxide emission, because sulfur content, because in this because we know that whenever we run any kind of 4-wheeler or 3-wheeler, we have seen a lot of smell sometimes coming out. That is mainly due to the presence of the sulfur present in the oil. So, that kind of problems we will not get in case of biodiesel, because it does not contain any kind of sulfur source. Now, other advantages is that it has the higher flash point, that is 100 degrees centigrade, and it is the only alternative fuel that can be used in a conventional diesel engine without modification. That you do not have to do any kind of modification, because I told you, when you use the ethanol also considered as a powered alcohol, but when it has been observed that up to 20%, if you substitute the gasoline, then whatever engine configuration is there, that cannot be changed, because with that configuration is good enough for running this gas engine. But when you go up for higher than that, then you have to change the configuration of the engine. Now, I have given the example of Brazil, and Brazil does not have any kind of crude petroleum. So, they solely depend on this cane, because they are the largest cane producer in the world, and they produce the alcohol they produce from the cane molasses. That alcohol they largely use as a powered alcohol. So, they changes the configuration of the engine, so that largely they can use the ethanol to a great extent for running this engine. So, so here in case of biodiesel, you do not have to do any kind of modification of the engine. Use of cooking oil and fat residue from meat processing may be used as a raw materials, because sometimes we have seen we have some different shops where we have different fried material. They use a lot of cooking oil, and this cooking oil, after some time, it is not of edible quality. So, this oil can be used for the generation of biodiesel. Now, this is the process that we have. Roughly it can be shown like this, that is the seed we produce from the plant, that which containing good amount of oil. This is the oil seed comes from the front, and then we do the extraction of the oil, so that we can get the good vegetable oil. Then we refined this oil through the refining process, and then it undergo transesterification. I told you, in presence of methanol and kind of catalyst, acid or alkali catalyst, it can be converted to monoalkyl esters, that is called this biodiesel, and that can be used for the operation of vehicles. This is how again a carbon dioxide whatever after burning whatever carbon dioxide is produced, that can be again utilized by the plant for this growth, and we can get again. So this is how what you call biodiesel cycle we can have in our system. Now that the raw materials used for the biodiesel production, that is non-edible and recycled cooking vegetable and the animal fat, that is largely used. Vegetable oils are rapeseed oils, soybean pulp and sunflower, that is largely used. Although the other oil are also used, including the peanut, linseed and safflower, then used for as a vegetable oil. Microalgae appears to be very important alternative for future biodiesel due to the high oil yield, because that I told you at the beginning that algae can be grow in a, it is considered the third generation of renewable energy source, because it can grow in a very small area, and also the fat content is very high, so we can use for the biodiesel production. Now this is the raw materials that we have for biodiesel. Rapeseed, how it looks. Soybean, this is palm tea, and this is the sunflower, this is used. The alcohol raw materials that is used, the methanol, the mostly widely used in spite of its toxicity, is the substance used for petrochemical of petrochemical origins. Ethanol is used very less amount because it required more complex production technology, and reaction speeds are low. It can be produced from the biomass. Difficulties arises in the phased separation and purification of biodiesel, where the ethanol is used in the reaction. So that is the reason why the methanol is mostly used for the biodiesel production. We don't use ethanol for the biodiesel. Mostly we use the methanol for this process. The catalyst, as I mentioned, that it is used two types. One is called basic, another is acidic. Basic means most frequently used at all production scales, like sodium hydroxide, potassium hydroxide, carbonate, and their corresponding alcohols. The acids that less frequency that is used, that is sulfuric acid, sulfonic acid and hydrochloric acid. Enzymes that also use very less, what we call lipase, that is used to a great extent. Now if you look at the oil that usually remain in the form of triglyceride. Triglyceride is like this. So it has the different hydrocarbons that we have here. So different organic acid, they form the esters here, you can see that. And the fatty acids, these fatty acids are may be saturated, maybe non-saturated. But one thing I want to point out here, usually the non-saturated fatty acid is usually preferable, because if it is saturated, there is every possibility of formation of solidification of the oil, that is undesirable, because the oil should remain always in the liquid form, so the burning characteristics the others we don't have any problem. So the most frequent fatty acid in oil is the lauric acid, palmitic acid, esteric, linoleic and the linoleic acid, although the others may also present. Vegetable oil may also contain small percentage of monoglyceride and diglyceride. They also contain not only triglyceride, they contain monoglyceride and diglyceride. Now characteristics of alcohol used biodiesel, I told you that mostly the methanol is used. Methanol is find most suitable because it is more favorable in case of biodiesel production process. The biodiesel is produced from the vegetable and animal fat or alcohol through the transesterification process. This reaction converts the esters into the mixture of esters of fatty acids that makes the oil. The biodiesel is obtained from the purification of the mixture of fatty acid methyl ester. fatty acid methyl esters, we call it PEM. And a catalyst is used to accelerate the reaction. According to the catalyst used, trans esterification can be basic, acidic or enzymatic. So we have different type of this trans esterification process, because we convert that alcohol to one form to the ester from one form to other form. That that is this take place in place of acidic catalyst, in place of alkali catalyst, or in presence of this what you call enzymatic like a lipase. In presence of lipase also it can be produced. So stages involved for biodiesel production: treatment of raw materials, alcohol catalyst mixing, chemical reaction, what you call trans esterification, separation of the reaction product, and purification of the reaction product. So these are the different steps involved for the biodiesel production. And the first is the treatment of raw materials. Some feedstock must be pre-treated before they go through the trans esterification process. Feedstock with less than 4% free fatty acid, which include in the vegetable oil or some food grade animal fat, do not require the pre-treatment. But if it required, it has more than 4% fatty acid, this required some kind of pre-treatment before this process. Now, treatment of raw materials: in this step, the feedstock is reacted with alcohol, what you call methanol, in the presence of strong acid catalyst like sulfuric acid, which convert the free acid to biodiesel. So your organic acid is in presence of methanol, it forms the ester, methyl esters of that particular organic acid, and that is we call is biodiesel. The remaining triglyceride is converted to biodiesel in the trans esterification process. I shall show you the reaction of the process. It is like this, that you can see that this is the ester that we have in the oil, and in presence of suppose this is methanol, there is CH3OH, in presence of acid catalyst, it produces suppose here you have monoglyceride, we have some kind of alcohol is produced, and here we get some kind of esters of the methyl alcohol, and this is called biodiesel. This is called biodiesel, and this is called trans esterification process. So here we have this ester, and it is changed to this ester. So one form of ester is changing to the other form of ester. So that is why we call it trans esterification process. When the methanol is the alcohol used in the trans esterification process, the product of the reaction is a mixture of methyl esters. And if you look at the catalyst, the alcohol used for biodiesel production must be mixed with the catalyst before adding the oil. The alcohol must be water free, it should be anhydrous. The alcohol to oil volume, the ratio R is another key variable in the trans esterification process, and it has been observed this should be 1:4. The necessary amount of catalyst is determined taking into account of acidity of the oil by titration. So this is the reaction that we have, chemical reaction. So this is the triglyceride, you can see, and in presence of methyl alcohol and KOH, it forms the glycerol, and we have this organic acid, different organic acid. We have different esters, we have what we call methyl esters with the R1, R2 and R3 we form. This is biodiesel, and this is so glycerin is a byproduct of the biodiesel production process. The temperature of trans esterification at atmospheric pressure usually in the range of 50 to 60 degrees centigrade. The absence of mono and diglyceride at the beginning in the chemical reaction, the reaction confirms the production of esters from the triglyceride take place in 3 steps. This is the triglyceride, then this is the methyl alcohol, this form diglyceride and methyl ester, then diglycerate in the methyl alcohol in presence of KOH, it produces monoglyceride and the methyl esters, and monoglycerate and methyl alcohol, it produces glyceride, glyceryl and the methyl ester. This is how it is formed. The separation of the reaction product, the separation of reaction product take place by decantation. The mixture of fatty acid methyl esters separate from the glycerin, forming two phases, and flame floats up at the top of the glycerin, settle down at the bottom. The two phases may be physically separated. In some cases, centrifugation is used to separate the two materials faster. So this is how we can separate the glycerol from the biodiesel. Now, purification of the product is like this. After the separation of glycerin, the flame mixture contains the impurities of some kind of alcohol, catalyst and unreacted oil. So this is to be separated out. These impurities confer the undesirable characteristics of flame. For instance, increases the cloud point, the pour point and flash point, that lower the flash point. In consequence, a purification process is necessary for the final product complying the standard. The flame mixture, what we call biodiesel, first wash gently with warm water to remove the residual catalyst or soap, dried and then sent to the distillation section for the further purification. The purification of this product, the glycerin contains about 50% glycerin, 40% methanol and 10% soap and catalyst. So this even we want to use glycerin, we can separate the glycerin through the phase separation process, but this remained in the lecture. So this can be separated, methanol can be separated through the distillation process, and this the soaps and catalysts can be used by by washing with water. Then first was then the salt is the removal unit, then the distillation unit. Now this process schematic that if you look at the flow diagram, block flow diagram is like this. We have waste, fat and oil, we have that acid and methyl alcohol, the free fatty acid pre-processing, then base catalyst and oil fat. All this the way you can do that, it comes to the trans-esterification reactor. Then we do the acid for neutralization and settling. Then we have the phase separation. In phase separation, we do the washing and drying and distillation. We get the methyl alcohol, we get biodiesel, we get the unreacted oil. And this phase separation, we can have the salt removal. Again, we have some distillation unit from which you get the glycerin as a raffinate and methyl alcohol as a distilled product. And this glycerin can be used in the pharmaceutical industries. This is the kind of block flow diagram that we have in the biodiesel production. Now I was talking about that microalgae also can be produced for the biodiesel production. We have been working with this algal fermentation process for more than a decade, and we had the collaboration I mentioned with the Oslo University, also the Uppsala University, Sweden, and also we have the collaboration with the Technical University of Denmark. Now we try to explore how this microalgae can be used for the biodiesel production. Our process is very simple, that this is the process, one process. There are three different processes through which the algae can be produced. One is called autotrophic, another we call heterotrophic, another is the mixotrophic. Now during the spirulina production, I discussed this process in details. So here I showed you the mixotrophic process, where the organic material, mixed organic material, can be used as a raw materials for the growth of algae. So here what is happening, this we have been working on biohydrogen production process for more than 2 decades, and we produce different organic waste, and we convert it to hydrogen, and after the fermentation is over, whatever the metabolites present in the fermentation broth, we take it in this photobioreactor, and then here we grow this algae, and algae can be grown in different reactors. You can see it is a sec plugs, then air-lift reactor and flat panel reactor. We get the biomass, then biomass is separated through the harvesting process, and through harvesting we get the cell mass, and this cell mass we contains a good amount of lipid. We extract the oil from that, and through the distillation the process, or from the solvent recovery process, and then we use this oil, convert this oil to biodiesel through the trans-esterification process. So glycerin is the main byproducts of the biodiesel production process. The use of glycerin has several in the pharmaceutical industry for the manufacturing of ointment, creams and lotion, in food industry for the manufacturing of sweet, then for soft drinks and pets foods, like and in the conservation of canned fruits. Is used as the additives for the soap. Different type of glycerin soaps is already available in the market, and it is also used for the production of nitroglycerin for the production of explosive. Now, in conclusion, I want to tell that a key environmental factor of using biofuel as an additive for the petroleum based transportation fuel is the reduction of harmful emission, and biodiesel is a process through which we can reduce the harmful emission to a great extent, particularly particulate matters, carbon dioxide and sulfur contents in the flue gas, in the gas coming out after the burning. The microalgae grown on in pond and photobiological reactor have been a great potential for the production of oil for biodiesel production. The stages of biodiesel production process are the same for all production scale: laboratory, bio scale, small, medium, large scale. However, the necessary equipment will be necessary for the different purpose. The biodiesel economy is concerned that according to the industry sources back 2007, that biodiesel cost is about $1 ton a gallon more to produce conventional diesel fuel when soybean oil is used as the primary ingredient. This makes the fuel about 10% more expensive than the conventional diesel, and it needs a tax break to compete with the petroleum based diesel fuel, because since the diesel has the some kind of advantage for safeguarding the environmental pollution problem. So if we can get some kind of incentive from the government, then price this price can be matched with the price that is we have in case of diesel available in the market. And in October 2013, the diesel fuel is selling around 3.8385 per gallon, and biodiesel is less expensive to produce than the conventional the diesel. Consequently, many truck stops are selling this biodiesel blends because they are not profitable than straight diesel fuel. The biodiesel has relied on federal tax break to make it economically viable. As long as tax break continues, then biodiesel probably has a strong future. because this is a environment, the great concern nowadays, and it not only affects our health, but also it affects the environment to a great extent, because particularly carbon dioxide that is coming out, that causes some kind of global warming, that is also we have. So this problem is a great concern. So I request you can visit this particular website to get the information more on biodiesel production. So in conclusion, what I want to tell that biodiesel is considered as a very effective fuel for running the vehicles. You don't have to modify the engine, because whatever engine is to use for diesel, that can be replaced by the biodiesel. The only the thing is that we still have to work out that the suitable sources for the biodiesel production. The sources are vegetable oil and the animal oil. So vegetable oil, if we make it cheaper, then our biodiesel also will be cheaper. The oil can be converted to biodiesel very easily with the help of methyl alcohol and the acid catalyst largely used for the. It can be used by using alkali and enzyme, but that is not used in the industry, because we find acid is more favorable as compared to other two processes. So and this has the pollution problem as compared to diesel. The biodiesel has some benefit. So we considered that biodiesel has a greater future, and also we try to explore that how the microalgae can be used for the biodiesel production. The microalgae might be the one of the important area, because we know the microalgae can grow much faster as compared to plant cell or biomass, the plant biomass. So if we can grow this the algae in the reactor very fast, then we can have more, and it contains high lipid and fats, then that can be used for biodiesel production. So that is all about the biodiesel. In the next class I shall discuss ethanol, biobutanol production. Thank you.